All right, everyone, thank you for coming. We have a good number of questions from the Google Doc. I'm going to talk about it as usual. And any follow-up questions, you can interrupt me. Otherwise, you can ask me at the end. Okay. Just for your information, you should have already received an announcement from me earlier this morning. There will be a Q&A session for the projects. It will be this Thursday, 4 p.m. Okay. In case you cannot make it, you can definitely just drop by my office hour, or you can watch the recording. For any code-specific question you want to ask me about, it's better to drop by my office hour or go to Schedule Labs. If you got any clarification you want to make about the game requirements, the best place to really get fast response will be go to the forum. So in that case, you don't have to wait until Thursday, right? Just to mention quickly. All right, so let's now talk about week number 9 lecture. Okay. So I kind of put the first 3 questions together. They're not really related, but they're all connected to design number 1, which is about the remote procedure call, the design attempt number 1 for the distributed client supplier system. I mean, the client server system. All right. Okay, let's go one by one. They're pretty straightforward, but I just want to mention the points so you will see. Okay, the first one. Basically, your fellow student was asking if we put these 2 lines of code over here in the constructor of current conditions. So are they going to use the alias with the weather data's attributes? Basically, that's the question, right? So to answer this one here, basically, your fellow student was suggesting that maybe we should really call the updates. So these are basically the updates command, what the update command is supposed to do for the current condition. Okay, let me show it to you. Okay, if you recall the implementation details from your slides, so let's look at the current condition over here, right? Let me show you here. So you can see this is the current conditions, in which case we only worry about temperature and also humidity, right? So over here. And then with whenever you want to get the most up-to-date temperature and humidity, you will simply use, basically, let me use the same color. So you're going to use the weather data over here. So now where do we get the weather data? So that's the question. So the way to get it is by establishing a link when you first create a constructor. So when you first, in the constructor, when you first create the current conditions objects. So it's exactly over here. Okay. So over here, I didn't really put a code, but basically over here, what you do is you're going to say weather data, which is an attribute over here. We want to create an alias, basically store the address of the remote server. So you're going to say weather data. Basically, it's assigned to WD. Okay, you can look up the implementation in your slide. It's exactly there. And what your fellow student was suggesting over here is to say, can we also put these 2 lines? And these 2 lines, as I just explained, is simply just the updates, right? So I simply say after this, I'll simply say updates. So there will be 2 lines over here for the constructor. I would say this is actually a good improvement to actually. Oh, so let me say it again. Sorry. So this would not be necessary. Okay. So there are 2 questions over here. Okay, let me answer your fellow students' question first. Are we still going to use the same alias? That's the first question. Let me answer that first, and that will make the second point. So now, basically, as soon as you say weather data is assigned to WD, right? As soon as you say this, remember this runtime diagram we have, right? So now, if we go to the current condition over here, right? So this is the object we are trying to create. So now, as soon as you say weather data is assigned to WD, you can think about the WD has its argument over here. So what we're doing is we're going to assign the weather data over here, the attributes to be the WD. So this is the alias link that we are establishing over here, right? It's very basic OO. And then let's say the following 2 lines is basically the updates. So when we say weather data and weather data over here, we are really referring to this particular line over here, this link. So alias is really being used for sure. So, okay, response to your fellow student questions, yes. And then it's really equivalent to updates. So that's point number 1. However, I would like to make point number 2, which is more important. As far as design number 1 is concerned, is this explicit call to the updates necessary? So this is my question. Okay, so I may have to open the floor to see anybody would like to try. So guys, this is my question. We are now considering design attempt number 1, which I assume everybody is kind of familiar with about design, not the observer, the design before the observer pattern. So now my question is like this. Let's say in the constructor over here, I'm going to add this extra line. Rather, in addition to just assign the alias of WD into weather data, okay, that was okay. But I'm just going to say additionally, I'm going to say updates over here. Would that be necessary? That's my question. Anybody want to try? You can type or you can speak up, either way. You can just tell me yes or no, and then just give me some very brief explanation for design number 1. So basically, I would say you basically got pretty much a pretty good summary of the class over here for current conditions. And don't forget, we also got this particular usage over here, right? So then, okay, I do have some answer over there. So let me just mention something before I get back to the chat. So you can see the most important thing is we want to make sure every time when you say current condition.display, when you're using it, it should be the most up-to-date. All right? All right, let me read a message over here, right? That's enough hints for everybody. Okay, so I got 1 positive and 1 negative. Okay, so let's see from Tim Pei. He thinks it would be he doesn't think that's necessary because of the aliasing. So you're saying that it's not necessary because of the aliasing. Okay, and for Amir, you say it's not necessary. We should call updates on demands. You know what? Since we're talking about design number 1, so we are not really calling updates on demand. Updates on demand is the case for observer pattern. So that's one thing you don't want to get confused if I ask you that on the quiz. So basically for design number 1, the clients is actually being very proactive. So every time they want to display, doesn't matter if the current data is up to date. Even if the current data is up to date, they will still do the remote communication to the server and call the updates, right? But we say that this is a drawback because you may be wasting network resources when unnecessary. So that's why in the design number 2, in the observer pattern, we try to do on demand. So that's what we improve. So we are still talking about design number 1. I think for Tempeh and Amir, your answer is partially correct. So this update over here is not necessary. Okay, first of all, not necessary. The reason you said was not correct. Okay, so why is that not necessary? Okay, it is because whenever you try to do display, the update is already invoked anyway. Always is the first step. Okay, because the first step of display invokes updates anyway. So doesn't really matter. So now if you look at this, for example, right? So now if you look at this example code over here, so you can see after we say cc.make wd, right? So now you can see the very first cc.display is over here. But now remember the very first step is going to call cc.updates as part of the first step of the display. So you don't really have to call the updates in the make. You don't have to, because always when you display, you always call the updates. Okay, so it's not necessary to do it over here. All right, so that's about the first point I'm trying to make. All right, guys, any questions about this? Everybody's okay? All right. So Robbie, did you want to say something? You're muted.
Professor?
Tempeh, yes, go ahead.
Yes, so if we don't have the update and we just only have the aliasing, let's
say this, yeah, okay.
Yeah, but like how does the data automatically update?
Great, okay. So basically what you're saying is, let's say we don't have the updates. So this is the version of the implementation that's given in your slides, right? So you're asking, if we don't have this, are we going to get up-to-date data? Okay. Think about, why do we want to get up-to-date data? What's the purpose for that? the purpose for getting the up-to-date data is whenever we want to display on the app, on the screen, we want to make sure whatever we display is the most up-to-date data. But this is already guaranteed by the first updates step over here. So that means the update over here will be unnecessary. Let's say this. If you say update over here as the last step for the constructor, and then you call CC that display right after, you're going to call the update for the second time anyway. So that's why this will be unnecessary. You see what I mean?
So I try to put the aliasing in the constructor. Let's say at first when we create this object, we do the aliasing in the constructor, and then the temperature and the humidity is pointing to it's always pointing to the weather data object, right?
Yeah, like this link.
Yeah. So if we put the aliasing, and then we just display. Let's say we just display the temperature and the humidity. Does it change automatically?
No, it doesn't change it doesn't change automatically, because remember, okay, think of it this way. I don't have the code over here. Okay, let me. It might be worth showing. Okay, just for completeness. Bear with me. Let me bring up the slides to show you. The short answer is in the display, in the body of the implementation for the display, you actually don't. You actually make use of the local copies. Let me show it to you. Just give me one moment. Let me bring the slides over here. All right. Okay. So the slides you want to go to is over here. Can you bear with me? So let's say we talk about current conditions over here. All right. So now, Tempe, look at this. If you look at the line here, so when we say we want to output to the screen current conditions, and look at which temperature we're using. We're using temperature over here, temperature and also humidity, right? So these are basically the local copies that's in the objects. But we want to make sure the temperature and the humidity are up to date. So that's why we have to call the updates over here. And the update is going to make sure the local copies over here will get the latest value from the remote server. You see what I mean?
Yes, I think so. So if let's say if you print the weather data dot temperature, it's
okay. I see what you mean. Okay, that's a good point. You're saying that is it possible to say rather than just calling update over here, which is going to update the local copy over here. Let's say we don't have the local copy. Okay, let's say we don't. In that case, you will simply say weather data dot temperature and also weather data dot humidity, right?
Yeah.
Okay, I would say in this particular example, since you're only using temperature and humidity just once, okay, let me just make my points precise, okay? Good, I was expecting somebody to actually raise this question here. That's good, okay. Let's say, for example, let me talk about a slightly different case for the display, okay? Slightly different. That will illustrate my points. Let's say we got our class current conditions. And okay, let's say we don't have the local copy anymore. So the only attribute we have is the weather data. So weather data, which is, I'll just say weather data over here, okay? And then we have our constructor, okay? And then it's gonna be WD, okay? Weather data. And then let's say the only line we do is to make sure the weather data is assigned to simply just WD, right? Okay, so far so good. And then what you're suggesting is, let's say for our display, and then we simply got do and end. So now there's no need to do updates anymore. So we can say we want to maybe print, we can say weather data, I'll just say weather data, just WD, right? Just to make it short. Weather data dot temperature. And also, you can also print weather data dot humidity. Okay. All right. So if these are the only two calls that you have, you know what? Actually, let me put it. Okay. If these are the only two calls to these two variables, then that will be okay. However, in general, for your routine, you have no idea how many times the display routine over here is going to make use of the temperature and also humidity. Maybe you need to maybe just have another one. You may want to say another to say print. Maybe you have some computation. I don't know. Let's say here you simply say current temperature is this. Okay. In that case, you're going to print out the current temperature. And for this one here, you're going to say what the current humidity is. And then you're going to print. But what if you want to print out the current temperature again? Let's say you may want to use it more than once. And then you're going to say WD over here, maybe temperature. For example, you might say maybe current temperature is not too cold. My point is, you cannot really restrict about how many times you're actually going to call the temperature. If you are going to call more than one time, in that case, you're really wasting your resources more than necessary. Because in the original version over there, if you look at that, again, if you look at the original version we got, once we have done the updates, we don't have to use a remote procedure call anymore. Every time we want to use it, we can simply use the local copy. So now, it doesn't matter how many times you're going to refer to the local copy. It's going to be local computation. It's going to be efficient. You don't need any network communication. Make sense to you?
Yes.
Good. All right. All right. So that's about this. Okay. Let me just read the chat quickly. Robbie, I was going to say because you call update in the display, what is I/O? Robbie, okay, that's good. I/O, you can think about I/O is a little bit like a system out in Java. So just a library for you to call for the print line. But I don't think that'll be applicable to your project, so you don't have to worry. Just whenever you want to build console application, so that's I/O you can use. All right. Okay, so we got one from Wei Ming. What about display do WD? For real, that would be the yeah, exactly. So waiting, so that's the point I'm just trying to say over here. So if you simply want to say WD.temperature and also WD.temperature, in that case, referring them twice is going to involve two separate remote communication. In that case, it'll be a waste of resources, really, right? So it's better to actually save them to the local copy. Okay, for Amir, practically we have to always call WD.temperature WD.temperature because we want the latest update. Yeah, so you're right. So we thinking this way, okay? So now let's go back here, and then that should be the last visit, okay? Think about this. Whenever we want to do this actual output over here in the display, we want to make sure the temperature and also humidity must be the latest one, okay? How can we make sure that's the latest one? So the current solution over here is simply say, we're trying to be very pessimistic. We're assuming that every time we call display, the local copies are already out of date. So that's why we always do updates, right? However, that turns out it might be way too pessimistic than necessary. That's why when we move on to the observer pattern, you want to make sure the clients is always passive. So whenever there's any update from the server side, the server will be the proactive one to really publish the updates. So they will call the notify, right, on the clients. And then we also say that, so what the new points we're trying to say today is about, you shouldn't really just get rid of the local variables, because if you simply just say WD the temperature and also WD the temperature, it's actually even worse for the performance. All right, okay. Okay, so that's about the first question. All right, let me see if there's anything else on the chat. Okay, nothing. Okay, everything has been covered. All right. Okay, let's see the second one. So if, let me see this, okay. If WD does set measurements is actually called from the clients, will that automatically updates because of the aliasing, okay? To be honest with you, I'm not exactly sure what your fellow student is really meant to say. I'll try to guess, okay? So WD does set measurement. First of all, the set measurements, okay, let's think about where a set measurement is used. If you're the one asking the question, please help me out to clarify your question. Otherwise, I can only guess. let me just erase this part here, just make it cleaner. Okay, so you can see that whenever we think we call set measurements, think about this is to simulate if there's any temperature, humidity, or pressure change on the weather data, right? So that's why the context object here must be the server. So when your fellow student was asking whether we should really do the set measurements on the client side, I guess maybe they were trying to say, when we actually say maybe after the updates, should we call the set measurements over here? And then pass some value over here, maybe WD dot set measurements. I'm not too sure if that's what your fellow student was asking. Oh, you asked a question. All right, so Tianpei, okay. Tianpei, would you mind just telling us what your original question was? So otherwise, if I'm halfway through explaining, I might just confuse everybody. You want to just tell us what your original question was?
I was just thinking about like how like from the client side how they manipulate the data, and I was trying to.
Okay, good. Okay, so let me finish up this question. Otherwise, everybody get confused. Okay, so guys, Tianpei's concern was like this. So should server be the only party? So should server be the only party who is going to initiate any change on the temperature, pressure, and humidity? Okay, the answer is yes. Think about what makes reality sense. In reality, should your mobile phone have the ability to change the temperature? I don't think it should, right? They're only the receiver receiving the most up-to-date data from the weather station. So that's why the set measurements should be the only. So the set measurement should be the routine that's defined on the weather data, the subject or the server actually. So the set measurements shouldn't really go to any of the client classes over here to change the temperature. Programmatically, it might work, but it simply doesn't make any reality sense. So for you guys up to this level here, for this, you're taking design course. So having something work programmatically doesn't really mean it's going to make reality sense. So for example, in this week, we're going to talk about a new design pattern, and then you will see that in some certain design, it seems to work programmatically, but it can simply give you something that doesn't make any reality sense. You will see that, okay? All right, so that's about the second question, okay? So the question over here, let me just make a remark over here. Okay, so now, no, you shouldn't, because only weather data should change its measure. Not the clients. Okay, I think it's just some conceptual confusion over here, right? I think that this is more to do with cohesion. You want to think about, as far as the cohesion is concerned, which party, weather data or the application, which party should really change the measure. So for cohesion purpose, it should only be the subject or the server. All right, good. All right, so let's now do another one over here. Okay, if we simply just create a query to return weather data, the temperature, and also weather data, the humidity, and simply call the query in the display, isn't this save time and space for updating? So I would, what you're suggesting is like this. Let me just use another, let me see if I got any code over here. Okay, let's say this. What your fellow student was suggesting is like this. So let me use the forecast, for example, okay? You can see for the forecast, you only, oh, you know what? I think it is maybe an even better one. Okay, how about I use this, statistics? It's easier to illustrate. Your fellow student was suggesting that, so now you can see for the updates, we simply just got current temperature is assigned to weather data, the temperature. What they're suggesting is, can we simply replace this one over here by saying this? For example, just by having a new query. You can say, maybe, for example, you can say latest temperature. And then this will simply just be a real number. And then do, and then n. Okay, so what should be the implementation for this? We simply say the result is simply assigned to, let's say where the data, I'll just say WD, okay? So the WD dot, basically the same line of code. The weather data is going to be weather data dot temperature, basically the same code, dot temperature. Okay, so once we have done this, so now for the display, rather than calling updates over here, so now we can simply just make use of the latest temperature. That's what your fellow student was suggesting. I would say this really boils down into the similar problem that we suggested before. So now, remember what we said before. If you basically just have separate call for WD, the temperature, and also WD, the temperature, it will be as if you simply say latest temperature and latest temperature. In that case, you're still making remote procedure call, because for each call to this particular query, you're making some remote communication because you're following through this link. So that's why this would not be a good idea. Okay. All right, I'll get to the chat in a moment, but let me just write some notes over here. Each invocation may, when I say may, I'm just saying that maybe the server, well, in the lucky case, the server may just be on the same computer, just different process. But if the server is geographically distributed, in that case, you will need computing resources to communicate to the server, right? May need to be a remote call. All right, so that's about third one. Is it possible to explain aliasing again? Sure. Is it just client-server relation, but the server is remote? Amir, when you say explain the aliasing, you mean aliasing in general, or just about how aliasing works in this particular example? In general, all right? Let me do both, okay? Basically, thinking this way. So basically, this might go to, back to your 1021, 1022, or 2030, right? Whichever course that you took before. So aliasing basically means more than, let me say multiple. That might be easier. Let's say multiple variables store the same, store the address of the same objects. Okay, for example, let me, okay, I don't want to go too much detail, but let me make it quick. Let's say if this is your memory, okay? So conceptually think about, you got different portions of the memory, and let's say this portion here is for this particular object. And the starting address, simply, I'll make it up. So let's say 062134. Okay, doesn't matter, right? It's simply some address over here. And this is basically the objects that you want to, that you can see. Basically, normally when I visualize, I'll simply say this is one object, maybe of type, maybe a smartphone, right? In that case, this is visually, conceptually how you can think of it, but this is really what's happening in the memory. Every object has some starting address, which for the allocation, okay? And now, think about it this way, okay? If I say over here, if currently, let's say variable x, okay? Let me say we talk about smartphone objects, okay? Let's say x is of type smartphone. All right? So now when I say creates x dot make, let me just make a smartphone object just to make it simple, okay? So now what that will do at runtime is it's going to store some address into x. So think about x is like a variable over here, storing address of smartphone objects only. Let's say this is the object that's being created for the smartphone, let's say. In that case, we're going to store 062134, right? That's basically x is storing the address of this particular object. Conceptually, you can think about x is really pointing to this particular object, right? Think about this is what's happening in the memory, and this is what's happening visually. conceptually, right? When you want to do visualization, right? Aliasing. Let's say I declare just another variable, let's say called y, also of type smartphone, let's say. And now if I say y is assigned to x, okay, what's happening over here, you can think about in two perspectives. Either you can think about y over here is going to simply copy whatever that is stored in x into here. So that means y is also going to store the same address, 2134, just the same address. That is why after this, when you say x equals y, is going to be true because they both store the same address, right? So now we got aliasing because you can see both x and y, they actually store the address of the same objects over here. So that's aliasing. And in general, it can be as many variables as you like that will store the address of the same objects. And how do you visualize this? You can think about y over here is really pointing to just the same objects. Amir, is that okay for a general idea about aliasing? Good. Okay, let me say a little bit more. Let's go on to our particular example over here. Okay, so that's why I kept saying aliasing for this particular one. You can think about all the object-oriented design pattern that we cover in the course, and also if you want to do any self-study beyond this course to learn about more object-oriented design patterns. It's all about object aliasing and also inheritance, right? So that's why these ideas are very fundamental to review. What is the application for the aliasing? Yeah, so exactly. So this will be one application. So now let's say this. Conceptually, you want to make sure all the objects over here, you want to make sure they are going to receive the data from the same WD objects, right? So now the way to do it is not to simply copy all the contents like temperature, pressure, and humidity into the object itself. You're not going to copy. So that would make the computation storage too big to really accommodate in your local storage, right? So what you do instead is by saying, for example, when you first create, let's say current condition, right? When you say cc create cc.make and wd, what you're doing is you're simply passing the address that is stored in wd and try to store the address into the weather data. That's all you do. You don't really copy individually the data over here. That's not what you do. You only copy the address of the server, which may be geographically distributed, right, to get there, all right? So now, let me say a little bit more to finish the discussion, okay? Let me just erase this. So now, so whenever, let's say, when you try to call the constructor for current condition, which is over here, right? What that would do is, it's going to say, for example, cc.weatherData, which is referring to this particular attribute, is assigned to WD. So what that will do is, it's going to copy whatever address that is stored in WD, which is the address for this particular objects. Store that address into the weather data attributes. Store that into here, right? So you can think about it's really like storing the address of X, which is over here, into Y. The same idea, right? So that's the application. All right, got it. Okay, very good. All right. Okay, and then after this, of course, you can think about visually you're doing this link. All right. All right, good. That's about aliasing. All right, so I think we finished discussing all the three questions about the first design, right? Good. All right, let me move on. All right, so this one here is a little bit about OOP. Okay. Also, it's about observer pattern. Your fellow student was not very convinced about the following. Okay. Let me again. So now we're moving on. We have moved on to the second design, right? We already say goodbye to the first design. So let's now the second one, the observer pattern. So let's talk about the observer pattern. If you recall the constructor for each of the client application, we have to establish a bidirectional link over here, right? So we're saying that the weather data should be assigned to whatever the argument is, right? So what we're doing is, for example, again, you can see this is WD, and so we talk about current condition. So what we're doing is, first of all, we want to make sure the current condition over here, that's an aliasing that we talked about previously. So that one there is going to point to this particular WD, right? That's number one. Symmetrically, we're going to say weather data dot attach. So the weather data over here is really referring to now the WD objects. And we want to say we want to attach this entire objects over here, this entire objects into as the first child of the observers list, basically, right? So how do we do that? The way to do that is simply by saying currents. And the reason we are saying currents is because, so at the moment, we are still calling this particular cc.make, right? Create cc.make. So that means over here, when we are executing this particular object creation instruction, the context objects, whenever we talk about context objects, in the case of Eiffel, we talk about the current keyword. In the case of Java, you talk about this, right? They're conceptually just identical, right? Nothing new. So the context object over here is simply just a CC, right? Current condition. So this is why when you say you want to attach the currents, you're really attaching the CC over here into this particular first child. So that means, visually speaking, the first child is now going to point back to this current conditions objects. Okay, so that's about how it works. But I think your colleague's question is about how can we pass the current inside the constructor, given that the idea about this particular constructor over here is to create the objects. How can you pass the objects before it is being created? Okay, so my response would be, what we are passing over here is simply just the address, right? So now, so this does not apply just to Eiffel, to any OOP, including Java, C#, or any language. So when you're first creating, when you're creating this particular object over here, CC, okay? Let me make the point over when started to be created, the address of the context object is already ready. And this context object over here is simply just the current. Okay, so your fellow student question was simply just about why could we do this? So I would just say that, yeah, you can definitely do it in OOP, because even though you're still in the process of creating CC, but the address is already ready. So you can definitely make use of it inside the body of the implementation. If you try to implement the observer pattern, for example, in Java, it will do it in a similar way by passing this into as the argument for the attach for the subjects. It will be the same. Okay. So I'm not too sure whoever asked the question was here is here right now, but just a basic about OOP. I'm trying to explain over here. All right, so this one's done. Okay, so now another one. So this one here is really about comparing the first and second design. Okay, I try to expand your fellow student's question a little bit just to make it a little bit more interesting, so we can compare. Let's see over here. We got design number 1 over here, design number 1, right? And also we got design number 2. And specifically for design number 1, you can see for the current condition we talk about it, we only call updates on the display, okay? And then for design number 2, for the observer design pattern, and then we try to establish the bidirectional link over here, and then we never try to call updates over here. So the update will be invoked by the notify routine from the subject end, right? So you can see over here, the only thing that's interesting will be the bidirectional link. So here's my question for you. In the test code that we talk about, I want you to consider an extra line, okay? Specifically, let's talk about current conditions. Let's say we create the weather data to be 9, 75, and 25. So you can see for the second version, also the same, right? And then let's say we also try to create a new object for current conditions, okay? And also we got current condition over here. So far, it's good, okay? In the demonstration for your lecture, I simply try to do WD.set measurements to be some new values. And also, I try to set it to be new values. Okay, we learn very well. This CC.display is guaranteed to really have the up-to-date value, right? Because the first step of the display is going to call updates anyway. And then this CC.display is also guaranteed to get the most up-to-date value because of the notify, right? So they will in both cases they will get the most up-to-date value, but for different reasons. So here's my question. Let's say this. Let's say I'm interested in displaying this particular initial value over here, 9, 75, and also 25, right? That's what I'm interested in. So let me say I insert one line over here in the middle, and the line simply say CC.display for design number 1, okay? And then I will also insert another line over here to say CC.display, okay? So now I got design number 1, I got design number 2. Which case, 1, 2, or both, or neither? Which case will I get the most up-to-date value for CC.display? Which one? 1, 2, or both, or neither? That'll be a question for you. Okay, I got some answers. You know, guys, just feel free to contribute. Which one will you get the most up-to-date value? Okay. I see one answer for number 2. I see one answer for both. I see one answer for 1. Okay, guys, keep coming. That's fine. I see another one, 1. All right. We're talking about the most up-to-date value. Which one will get, right? All right. So what should be the answer? Okay. For those of you who responded, thank you. So the answer should be only 1 should get the most up-to-date value. And the reason is very simple. I kind of hinted that to you already, okay? The reason that when you call CC.display over here, is actually going to get the most up-to-date because for the display itself, you always call update first. So no question about it. Doesn't matter when you call display. You will always update first before you can display anything, right? So now for number 1 over here is going to be up-to-date. So this one, no question. Okay, I'll say yes. Because the first line, the update over here is always going to be called. So that's the reason, okay? So that's why 1 should, for sure, will get the most up-to-date version, all right? So now the question is, what about design number 2? Should it be, would it get the most up-to-date or it wouldn't be? All right, that's a question. It turns out it wouldn't get the most up-to-date value. Why? Let's see. Think about what's happening over here. Before this particular extra line to say CC.display, let's see what happens beforehand. Before that, all we do is to create this particular current conditions objects. And what does it do? What it does is it will simply just establish the bidirectional link. Let's now visualize this very quickly, right? Let me go back here. So you can think about what we're doing is, you know what? Let me just draw a new picture. Okay. What's happening over here is CC. We're creating this particular new objects. Okay. You know what? Let me just go by sequence. We start with this particular WD data over here. So that'll be the weather data. Okay, I'll say WD. And that one there has temperature. That one has humidity. And also it has the pressure, right? I don't quite remember the order, but that's okay. So that one is initially it's going to be 9, 75, and 25. Okay, 9, 75, and also 25, right? That's basically what this line does. This line. And then this line over here, according to the definition, it's just going to establish the bidirectional link. So what that would do is like this. Oh, and then don't forget, we also got a list of observers, right? Or OBS, right? It's going to be a list. Initially, simply just empty, all right? So now that constructor over there is going to create the bidirectional link. So what that will do is, first of all, it's going to say CC. It's going to be of type current conditions. And then don't forget that for the current conditions, according to the definition for the current conditions, I don't show it over here. Let me see if I got it. Just give me one moment. For the current condition, okay, it's actually the same as the first design. That one simply just contains temperature and humidity, right? And also weather data, the same. So that one got temperature and also humidity. Initially, simply just 0, right? And then we also got the weather data. And then the link is going to point to WD because of aliasing. And also the first child of the observer is also going to point back. So that's all the constructor would do. But that one there wouldn't set these two values to anything other than the default, right? So now this is basically what has been done after this particular line. So now if we try to call, oh sorry, after this line, beg your pardon, after this, we're talking about a second design pattern. So after we call cc.make, we have already established the bidirectional link, and then we simply going to say cc.display. So now, are we going to get 9, 75, and 25? No, we are not, because at this point over here, we still got 0 and 0. Right? So that's why over here, up to date, no. It is not the case. So the question would be how we can fix this. That's really the question, all right? So there are different ways you can fix this, okay? So I would say one way to fix this, okay, how about fix? Anyone want to suggest a fix? So now you should know why this particular, for design number 2, so there's a potential flaw over there, but in the illustration, I simply assume the first CC display only occur after the notify. That's my assumption over there. And actually, if you go to your video, I actually responded this particular question to. I did respond this. Let me just show. I did mention this in the lecture. I'm not sure if you actually watched, pay attention to that part. Let me show it to you. So for those of you who just want to just rewatch this part of the lecture, only a few just 1 minute or so. Let me just get there. Give me one moment. Okay, good. So basically, if you go to Google Doc, so this is the relevant remark I made for this particular design. So if you go to your lecture part 2C, right, for week number 9, and then go to this particular timestamp, 5 minutes and 9 seconds. Go there, and then you will see exactly what I said about this particular fix. Okay. So now, what should be the fix? The fix would be, okay, just to save everybody's time. So the problem about this particular CC that display being inaccurate is because in the constructor over here, we didn't do anything to actually keep these two values to be up to date. Well, why don't we keep it up to date right after the constructor? So what we can do is the fix. So the fix will just be, you can say, at the end of the at the end of the implementation for the constructor, you can simply explicitly call updates preemptively, basically. So this will be the only time for the observer pattern for the clients to initiate the updates. So that will be just to handle this boundary case. All the subsequent updates will not be initiated by the clients. They will all be initiated by the supplier. I mean the subjects. Okay. Wei Ming is suggested another interesting solution over here. Okay, let me talk about it. So he was wondering whether we should. So this will be one alternative, just simply called updates. So Wei Ming is suggested another line over here. Why don't we say WD dot notify? Anyone would like to criticize on this? So when I say criticize, doesn't really mean it's bad. So if you want to support this line over here, you can say so. So what about we simply say by the way, this is WD, right? Just to make it clear. So so let's talk about this is solution number 1. This is solution number 2. Do you guys think number 2 will be better than number 1, or they're simply equivalents? Anybody? So Wei Ming, you asked the question. So why don't you answer me first? Do you think number 1 and number 2 are they equivalent, or you think this one will be better than this? Anyone? Maybe notify is better. Okay, Amir, that's okay. I appreciate you speaking up. So you are thinking that maybe this one is better. You know, in some way, because notify has been developed already, right, from the supplier side. Okay. Somebody, Wei Ming, think they are equal. For Amir, you think there might be less. There might be, if you call notify, there might be less network resources. Okay, I'll take your point just for now. And then Tianpei actually said it's remote, so costly. Update over here for sure will be remote, because for the updates, you're actually going to remotely update the temperature and also humidity, right? So Nina actually pointed out the important point over here. When you call WD.notify, how many observer would that notify? Well, depends on how many observer there are. Let's say, what if there are so many observers already in the WD, right? So now let's say they already all point to some other observers, you know, at the runtime. Let's say they all point to something else, right? So now you're saying that in order for me to create this particular new client objects, I also need to bother to notify all the others, in which case all of them are going to make the remote call to the subject in order to update. So do you think number 2 is really the way to go? Maybe not, right? Okay. So number 2 over here potentially is much more costly. It's not really surgical, right? So this update here is surgical because you're only trying to update this particular current condition that's being created. On the other hand, if you say WD.notify, you're basically saying for all the well-established observer that's of the current WD, you're going to update them as well, but it may not be necessary. Guys, I hope you see my point, right? Okay, let me write it down briefly, right? I think that's a good point, actually. So WD.notify over here. So this will be very costly because all the observer will be updated. All the observer will be updated. Sorry, I'm just writing out of space. I'll try to just make updated. Okay. Let me just write it properly, right? I really think that the discussion itself is really important. So you really want to see, whenever you think about different alternatives to really improve your design, always think about what the consequence might be, right? That's really important. So WD.notify over here, I'm going to put it over here. This will be costly because all the observer have to be updated. So individually, they're going to also waste the network resources. So you're not really affecting just yourself, but also others, right? Okay, good. Okay, if that's clear, that's good. I think it's worth the time discussing this. Okay, so that's about this one here. So guys, I think this discussion here is very nice because that really kind of compare the two design attempts, right, before we move on to the event-driven design. So Chen Qi, so can we add notify into make and set measurements so that they every time a change happens, notify all the observers about the change? So are you talking about, okay, you're talking about two things over here, okay? So now we are talking about observer pattern, right? So let me see, do I have, I don't have the subject code over here. Okay, that's fine. So let me talk about the first suggestion you are talking about. So you can see somehow WD.set measurements and WD.notify. So these are actually a separate calls. So I'm pretty sure I mentioned that in the video. Okay, just mention again. So potentially you can say as part of the set measurements over here, the last line for the set measurement, you can always just call notify. So this will be okay. And I would refer you to the event-driven design. If you go to the event-driven design, let me just show to you right away so you can see the connection, okay? And then I'll talk about the second suggestion you're talking about, okay? Let me just go to the code over here. If you go to event-driven design, actually both for Java and for Eiffel, let me show you the Eiffel version. Java version is the same. Actually, for the Java version here, you can see as part of the set measurements, we actually publish the updates to all the events. So conceptually speaking, it's really analogous to in the observer design, as part of the set measurement, you try to notify all the observer, right? It's analogous. In the Eiffel version, you will see something similar. In the Eiffel version, if you go to the weather data, you can see as part of the set measurements command, after all the local changes on the server side, you try to publish to the events right away. And one thing to clarify the confusion, in the observer pattern, you basically try to notify all the observers, right? The subjects try to notify all the observers that subscribe to it. On the other hand, for the event-driven design, the subjects does not directly notify the observers, right? Because for the subject, they do not maintain any list of the observer. Instead, the subject will publish to the events, and then the events maintains a list of delayed execution from the function, right? Okay, that's something you want to make sure you don't really get it confused. So Chengqi, so you said that we can add also the notify to the make. What do you mean the make? The make of current conditions or the subjects? What do you mean the make? Are you talking about adding the notify into the make of current conditions? Is that what you meant? If that's what you meant, we already discussed that option number 2 over here is very costly. So that's not what you want to do. But adding the notify or adding the notify into the set measurements, yes, that will be okay to do. Okay. All right, assuming that you're okay for that. All right, so let's now move on to the next one. Okay, so let's see this. Let me look at the time. We still got half an hour. Okay, good timing. This is the only this is kind of the only technical question about event-driven design I have. So can I give an example? Sorry. Can I give an example of how the implementation of events will be if there are 2 subjects? All right. So I'll try to guess. I think I can see what your fellow student is trying to ask, but the exact wording may not be so precise. So basically, they were asking, should we modify whatever implementation we are given for the slides, right? We talk about event-driven design for both Java and Eiffel. Let me talk about the Eiffel part, which because that was simpler, you know, for the coding. If we have in our, let me just be precise over here. If you look at the example test code over here, all right, so this is example code for the testing, right? The weather station. There is only a single subject, which is weather data. And your fellow student was asking, what if we got multiple subjects, okay? So now I would say over here, there are 2 cases by what you meant by multiple subjects. It could be that we still have just the weather data class, just a single weather data class. And then we actually got multiple instances of the same kind. So maybe you got weather data 1 and weather data 2. Okay, that's case number 1. Let me distinguish between the 2 cases, and then we'll talk about resolution for each one of them. Right? So case number 1, we got multiple instances. So maybe we got WD1 and WD2 of type weather data. This is case number 1. We basically got multiple instances of the same class. All right, that's case number 1. that could be one. That could be one interpretation by what do you mean by two subjects. Another interpretation could be maybe we actually got two different subject classes, meaning that not only that we got weather data over here, we might just got another class called weather data 2, for example. Okay, let me just sketch the idea. So maybe we simply got another class over here. Sorry, let me draw again. Maybe we simply got another class over here. Okay, over here. And then, so here we simply got another class. Maybe call that weather data 2. So the 2 can be is maybe just another weather station, or maybe simply just maybe weather data from a different region, different part of the region, for example, right? Okay, and then in this case, maybe we got WD1 of type weather data. And then here we got WD2 of type weather data 2. Guys, first of all, I want you to understand the distinction I'm trying to make between the two cases. Okay, so one case is you got only one kind of subjects, but you got multiple instances. And then the other case is you got you got multiple kinds of the subjects, and you also got multiple instances. Well, these are the two cases. Any questions about the distinction over here, first of all, before I move on? Everybody's okay? All right. Okay, the chat is quiet, so I presume everybody is okay. So now the question is, for case number 1, in this case, we still just got this single weather data class. What happens if WD1 and WD2, let's say WD1 may have some updates, and WD2 also have some updates. What's going to happen, right? Think about what's going to happen here. Basically, think about WD1. Let me use different color over here to show you. And WD2, right? That's a green one. At a runtime, what's going to happen is maybe WD1 is pointing to some weather data, right? This class over here. So it's going to be weather data. And notice that since we talk about event-driven design, there is no observer list. No, all right? So we got temperature, and we got humidity, and also we got pressure, right? So I'm gonna talk about the value in just a moment, just for example. We got another one which is WD2. That's of the same type, right? Just weather data over here. And then also we got temperature, we got humidity, and also we got pressure. All right, so the same object structure. Okay. Let's say this. Let's think about how things are going to work. If we now say WD1 dot set measurements, all right, set measurements. And then I'm just going to put some values over here, for example. Okay, I'll just put something. Okay, let me just make it very simple. What about 10, 20, and 30? All right. And then let's say a few moments later, if I got WD2 dot set measurements, maybe it's going to become maybe 12, 18, and then 41, for example, right? So at a runtime, you can think about WD1 and WD2. They are simply two independent weather data that might be geographically distributed. And then they might just maybe update their measures at different timings, right? That's what's happening right now. Okay. So now, do we need to extend the code for us that's given to you? The answer is you don't have to extend the code. Whatever we got over here, you can see. Remember about event-driven design. Let me just mention an important diagram that you want to pay attention to, right? Let me bring back the slides. If you want to review about event-driven design, maybe later on for the exam, you want to always remember what this diagram is really trying to tell you, right? Think about WD1 is basically weather data. WD2 is just another weather data, right? So now if WD1 caused the set measurements to change its measure, what it should do is it's going to publish the updates, not to the observer. We are not talking about observer anymore. What that will do is it's going to publish the updates to the relevant event, the relevant events. Maybe the change on the temperature, change on humidity, and etc. I'll show you the code in just a moment. And similarly, for the WD2, which is going to set a measurement slightly later, that one is also going to publish to the same events over here. So now, how can we be sure when the WD1 published to the relevant events, and also when WD2 is also published to the relevant events, are they really publishing to the same events? Are they or are they not? It's really important. If they are not publishing to the same events, we have inconsistency. So now I want you to come back to this particular code over here. Now, take a look at this. So these are the relevant events. Since for the illustration for your lecture, I simply just say this, we assume there's only a single kind of subjects, but we may have multiple instances of that, right? So now these are the 3 events. So now from the code over here, you know every syntax over here, which part of the syntax guarantees whenever you try to publish to the events from different server. For this subject published to the events, for this subject published to this events, what construct is really guaranteeing that it's going to be the same events, objects? What construct? Which construct? If you look at this block of code, what construct actually guarantees is always going to be the same set of 3 event objects they will be published to? Let me post the question over here, and then hopefully somebody will be able to answer to me once I'm done. Question: which construct ensures the same 3, right? Since we'll talk about temperature, humidity, and also pressure, the same 3 events, instances are being published. All right, very good. Yeah, Amir, you said singleton. Yeah, that's pretty much it. Yeah, because you need once to support singleton. Very good. All right. Okay, the answer is once. Very good. So now I think this is really to remind you that use of once over here is very crucial. If you don't use the once keyword over here, so that means every subject might just publish to different events, right? So that would be inconsistent. All right. Okay, having known this over here, so all we have to make sure is that'll be okay. So now this will simply just work at a runtime. Think about how it's going to work. When you say over here, let's see this. When you say WD1 dot set measurements 10, 20, and 30, right? First of all, so it's going to simply call the set measurement over here, right? It's going to update the local measure over here. It's going to be 10, 20, and 30. It's going to be 10, 20, and 30 over here, right? And then as soon as this part is actually done, it's actually going to publish to the relevant events over here. And then once you publish to the relevant events, the other end of the story is the event itself is going to call the store delay execution for all the updates for the observer, right? That's the other end of the story. So I'm not going to mention here, okay? Okay, and now if you try to do another one, let's say if you try to say WD2 dot set measurements and then 12, 13, and 41. So that'd be 12, 18, and then 41. So what this will do is it's going to update also the local measure over here, and then you will publish to all the same 3 relevant event instances again. So that will make sure the other end of the story is it's going to again from the event side is going to call the updates operation on the observer for the delay execution. All right, guys, is it okay for case number 1? Case number 1, when you have multiple instances of the weather data, just one kind, no change will be needed for the code you're given for the lecture. Okay, it's gonna just work. However, I think this one is the question is good because this one can make sure you really understand how the multiple. Let's say this. In this case, let's say for example. Let's say let me just take one for example. Let's say change on temperature. Change on temperature. So this is one of the events. Okay, one of them. So think about WD1. When WD1 try to publish the update to change on temperature, and that one there is actually going to invoke the updates to all the updates. It's going to invoke the store the pointers to the update function, right? To all the clients, maybe CC, FD, and SD, whatever, right? Just for example. Okay, and then when we actually try to do this, so when we say WD dot set measurements, so now when you say WD2, and then you're going to publish this update to the same events. After this, it's also going to call the updates to every one of the client application by calling the pointers that you stored previously. All right. Okay. Any question about case number 1? Everybody's okay. So understanding the need for using once is very important. We still need this for case number 2. All right. Let me at least finish all the questions that's on the Google Doc today. Okay, I'll try to speed up a little bit. Okay. So what about case number 2? For case number 2, since now we actually got 2 classes over here, we got weather data 2 and also weather data, right? So I would say, programmatically speaking, let's say this. When you say WD1, let me change the color over here. So this may be better be green. Okay, so now when you say WD1 dot set measurements, let me use the same number, okay, 10, 20, 30. So guys, this one will be very easy because for that one there is simply just make sure WD1 is simply just going to point to, just going to publish to this particular event, right? Maybe change on temperature. That one's okay. However, the problem is, when you actually try to call WD2 dot set measurements, that's the problem. I tell you what the problem is. 12.18.41. So that means the set measurements has to be somehow declared inside this particular second class, right? However, inside over here, you can think about, of course, we can update the local measure. That's the first part, right? This first part over there is simply like the first part over here. That's not the issue. The issue is, now, how can we get access to these events, right? That's the problem. Access to events. That's the question. How can we get access to it? We can use inheritance. While you're saying that, okay, so Tianpei, I suppose you're saying that, for example, you can have maybe, for example, weather data over here, for example, and then you declare all the 3 events over here, and now we got weather data 1, and also we got weather data 2, inherits all the events, right? Is that what you meant? Yes, that will work. That will work. However, this will only work if you're talking about the 2 subjects over here are cohesive enough to be called weather data. But what if, I'm just saying what if this class over here has nothing to do with weather data? Maybe it has something to do with, I don't know, maybe some remote office, in which case they will also want to update the temperature, but then they are not really weather data, right? In that case, whenever you want to have 2 sibling classes, so that means somehow they really should belong to each other because they have a common parents. But now, if these 2 classes simply have nothing to do with each other, you don't really want to put them under the same superclass. So I would say your solution works in a limited scale. Okay, so that's why I wouldn't write it down for now. Inheritance is not a bad way to start. I'm just saying cohesion can be one potential issue you want to watch out for. Okay, there will be at least 2 create metadata inside metadata 2. No, you don't want to do that, because why would you want to introduce a client supplier to say inside metadata 2 you simply got metadata? But what will be the measure you want to set to be metadata, right? It's just confusing conceptually. Programmatically, it might work, but I don't like the design. Yeah, exactly. Good. So guys, I think there are at least 2 solutions to this. Let me mention about the 2. Okay, at least 2 solutions. I'll try to finish this by 7 p.m. And then there's 2 more questions specifically to the quiz. I'll talk about it. That'll be very quick, just about a few minutes. Bear with me. So now, how do we solve this? 2 solutions. I'll sketch the first one. I'll sketch both. The first one over there will be to use a singleton pattern. Maybe you can have, for example, something like I would say, when I say singleton pattern, I would say adapted. How about that? It's not exactly the singleton pattern you learned about. Basically, I'm just trying to make use of the ones keyword, adapted. Okay, I'll just say adapted. Okay, let's say you have a class called utility. All right, maybe you can make it expanded if you wish. Okay, so you don't have to declare. You can just declare the variable and then just use it directly. Right. So this and then think about how we use the model access class. In the model access class, you just got a single routine, which is going to return the model type, right? So now for the utility, why don't we just return? We just got multiple routines. Each one of them is going to return the events. So what I meant by was this: change on temperature is going to be events of tuple real. So I already explained what this really means. Okay, it's going to be a tuple of real. Okay, that's a return type, and then it's going to be once creates result.make end. Basically, you can just do this for each one of them. Okay, let me see if I can just do some very quick copy and paste, and then I'll talk about the second one. Okay, this will be the first one for change for temperature. And then you can do another one. Okay, like that. I'll just do 2, but you see the idea. We got another one, maybe change on, let's say pressure. Okay, so you just got different events over here. So how do you use it? The way to use it, okay, let me just, so how do you use it, right? The way to use it is you can declare maybe some access. Let's say events access. Let me just say EA, put event access. You can say event access over here. Oh, you know what? Assuming that this is already declared, so you can say event access. So that will be utility. And then, so now let's say inside the measurements for, so now you can think about these 3 events have been factored out. Okay, so these events have been factored out into this particular utility class. That's what I'm doing, right? And then inside the measurements, you're not just going to do the publish slightly differently syntactically. So now you're going to say, for example, you're going to say EA dot C on temperature dot publish. You can see the only difference is how you get to the C on temperature. Before you can simply just say change on temperature and change on temperature because that's in the same class. But now we have factored out all the events into this particular class. So that's why you just need an EA over here, right? Everybody okay with this first design? Okay, that's the first one. Let's see the second one. The second one got very similar idea, okay? So the first one is about singleton pattern, right? And the second one over here is about static methods or static routines. Let's see how we can do that, okay? The second one is going to be about static routines. All right. Remember, we talked about the special post condition with the class keyword, right? So now, why don't we try? Let me still put a utility over here. So I would say class utility. So now this time it does not have to be expanded anymore. All right. And then we got the end over here. All right. And now we say C change on temperature, right? So now just for abbreviation, I'm just going to mention one of the events, but you can generalize it to 3 events. Change on temperature is very similar to before, so it's going to be events, and then it's going to be tuple of real. Okay, the same as before. And then it has to be once, right, for the singleton instance part. That one's the same. Result dot make. So now what's going to be different for this second solution is you're going to say ensure class. So this is a crucial bit. Ensure n. So the n for the class should go a little bit lower. All right, guys. So far, so good. All right. It's basically the same idea. I'm just trying to say in both cases, you can see in case number 1, I'm trying to use the EA, which is expanded, and then I'm just trying to use that to call, right? So now, after this, we are just going to see how exactly you can use it. How do we use it? So now inside the set measurements for the weather data, and also inside the set measurements for weather data 2, we're going to call these events for publish, right? Well, how do we call static routines? Do we need to create an object of type utility? Hopefully you don't think we should, right? Because that's the point of using a static routine. All you can do is you can say utility, and this actually comes from your lab number 0. Utility dot see on item. You can see you don't even have to declare. Compared with the first solution, you can even save the object declaration, and then you can say publish. Oh, sorry. Let me move this a little bit to the left. Make it a little bit smaller. So I can sit in one single line. Dot publish. Whatever data it is. Okay, so that's the second solution. Guys, any question about case number 2? You can see for case number 2 over here, I give you 2 solutions over here. Either you can try to use the adaptive singleton pattern where we got mainly once routines over here, or you can simply use what we learned from lab number 0, in which case you can simply call the events as a static routine, in which case no object need to be created, you just use a class name. Yeah, you can call all the events in one class. Yeah, exactly. Well, guys, good question here. So should you say this solution here is better? Well, is this solution better? Any opinion? I would say, to be honest with you, if I were to program this myself, I might tend to go with this one here because this one saved me writing the line for decoration. But as far as the design is concerned, I don't see any, if this design is superior than this one or vice versa. I don't see that. So conceptually speaking, both of them, the fundamental construct that makes both approach work is the once routine. And also we put all the events into a single class. So both of them actually also satisfy cohesion. So both. Let me mention that point over here. So both solution satisfy cohesion. because you simply put all the relevant events into a single utility class, right? Put all the events into a single utility class. But exactly how you use it is going to up to your personal preference, right? Will expanded class takes up extra space? I don't really think so. Not really. I don't think the storage, the extra storage will be something you have to worry. Not really. All right, guys. Any more questions you want to ask regarding these two solutions before I move on to the final bits? And then hopefully I can finish in time. Any more follow-up question to this particular one? So as a recap, the very original question from your fellow student was about having multiple subjects. And then I simply just want you guys to be a little bit more careful. When you say multiple subjects, you have to be clear about whether it's about multiple instances of the same subject class, or it's about multiple instances of different kinds of subjects. So it makes a huge difference, right? So that's why I can show to you for case number one, it will already work out of the box, given the code that that's discussed in the lecture. But for case number two, since we're going to also use a separate class for more subjects, in that case, having these events over here into a single class is not going to be feasible, right? It's not going to be good design, because how can you access these events from all other subject classes, right? That's why for cohesion purpose, we try to put all the events into a separate class. That's called a utility. And how you implement the utility is kind of up to you. Either you can use the static routines or you can use expanded class, right? But the fundamental idea would be you still have to use the once keyword. That's really important. All right. Hopefully no more question about this, I hope. Okay, let me talk about two more questions and then we're done. Okay, one question is about clarification, okay? If I understood correctly, method handler, when we talk about Java solution or procedure in Eiffel, they are simply just library classes which help us to store functions features. To be more precise, you store a pointers to them, like the referencing operator you learned from 2031, right? About the C pointers into an object so that they are easier to be stored and retrieved. That's pretty much right. You want to say it's easier to be stored for delay execution. That's something I would like to add. Otherwise, the explanation is pretty accurate. All right. Okay, final question over here. In terms of our quiz this week, quiz number 9, do we need to study event-driven design in only Eiffel syntax? I would say when you study the Eiffel syntax, which we pretty much reviewed today, right? You want to know about how the once keyword is being used and also how to use the agent keyword, okay? For sure, right? Do we also have to study the event-driven design in Java syntax as well? I would say the following, okay? You don't have to memorize. Do not memorize any Java code. Okay, number 2, you want to understand how the classes work together. Okay, and number 3, if there are any questions on the Java or the Eiffel, basically, when I say Java, also applies to Eiffel. On the Java design specifically, like how you do the Java event-driven design, the API will be given to you, so you don't have to worry. You don't need to memorize any method name or any will be given to you. All right, guys, any questions? Any more? We are pretty much about time to stop, but I can take a few more questions if you wish. Anyone? Everybody's happy?
Can I ask a quick question from?
Yeah, go ahead. Yes.
From the project. So for the random number, like, so we have to call first two first, and then we can see the random number, right?
You mean, are you trying to say how you can debug the random number generator?
No, because I look at the starter code, the root class. It says we have to call first two. I mean
No, actually, okay. So basically, let me just put it brief. So the way you use a random number generator should be very similar to how we demonstrated in the root class. So what we set over there in the root class is, for the very first two numbers you generate from there, is simply just going to return the minimum number from the range. Right? That's what we demonstrated over there. Yes. Starting from the third number for your random number generator is really going to be random. So now another question is, where should you use the random number generator? You should only use it at the end of the turn, like a phase number 7, when you want to spawn the enemy. Does that answer your questions?
Yes, so like we always have to call this at least 3, right? Because we have to make the first call, then in the third call, that's really regenerate.
No. You should no. What I'm saying is, so thinking this way, the very first 2 times you call the random number generator is at the end of the first turn. The third and fourth time you call the random number generator is at the end of the second turn, and so on.
Oh, I see. Yeah.
Okay, see what I mean? Yeah, feel free to put this question on the Google Doc if you, I can clarify again, maybe in the Q&A. All right.
Okay.
If it is a random number generator, then how come the result of our code and project will be the same? Okay, it's a good question here. Okay. Well, that's not really relevant to your quiz number 9. Okay. It is because, to be more precise, when we say it's random number, right? There is another, there's a missing qualifier over here. It's deterministically random number generator. Deterministically, meaning that based on the seed of the random number generator we set up for you, which you don't have to know exact details, but based on the seed for the random number generator, the sequence of random number random number generator is going to be basically predictable, meaning that if you try to use the random number generator in the same way, then using them separately is going to give to you the same sequence, basically, right? So think about the sequence that's being generated. Let's say this is the sequence, let's say sequence number 1 is by your program, and this one here is by the Oracle. If they are simply being called with the same interval for every usage, in that case, the numbers are going to be pairwise the same. So that's what I meant by deterministically random, right? Okay, anyway, so it's a little bit technical, yeah. All right, guys, don't worry about the project. I'm going to have a Q&A on Thursday, so you can feel free to ask me more. But let me just ask one more question. Do you have any more quick question for your week 9 lecture before I move on to, otherwise you can ask me tomorrow. Okay, final question for the project. Do we need to skip the first 2 numbers by the generator? No, you don't skip them. No, you don't skip them. Okay, any more questions about the lecture? All right, there's a Google Doc for the project's Q&A, so put your questions over there. But I would say if the questions are somehow urgent for you or somehow complicated, in that case, you may just want to put on the forum. You might just get your answer right away tonight. All right. All right, guys. I'm going to end the session now. If you got more questions, if you can make it to tomorrow, you can still come. All right. Tomorrow we'll continue with week number 9, lecture Q&A. All right. All right. Have a good night. Talk to you later.